Hello everyone, welcome back to another important video of the DSS series. So today we are going to discuss about the most important and repeatedly asked interview question. So let's understand the question. The question is kth element of the two array. So let's understand the question first. So in the question we have given two sorted array A and B and an element K. The task is to find the element that would be at the kth position of the combined sorted array. So let's understand the question with the help of example. So in the given example they have given that we have two array A and B. So in the A, both the array contains the element in a sorted array, in a sorted order, and we have to find out the element at the fifth position. So we have given the position value where we have to find out the element. So let's understand how we are going to let's firstly combine the element of both the array. So after combining them in a sorted order, the final array will become 1, 2, 3, 4, 6, 7, 8, 9 and 10. So at the fifth position the value is 6. So this is our resultant answer. Okay. So I hope that that question is clear to you. So it means that simply we have to find out the kth position value after combining both the array in sorted order. So let's understand what is the first approach, what is the brute force approach through which we can solve this question is that as in this example we have created another array called C, which will going to store the all the element from both the array in a sorted order. Let's firstly pick, we'll take two pointer and we will check that either the 1 and 2 which one is smaller. So 1 is smaller, so we will store the 1 into the third array and we will update the we'll update this pointer, we'll update the right pointer. Got it? So now again we will check 2 and 4, which one is smaller. 2 is smaller, so we will place the 2 here and we will update this pointer, right? So after that again we will got here 3 and 4, which one is smaller. 3 is smaller, so we will put 3 here and we will update the left pointer. Now the left pointer is pointing to 6. Now we will compare 6 and 4, which one is smaller. 4th is smaller, so again we will put this 4 here into our resultant third array. So in this way we will store all the element in sorted order. After inserting them, what we will do, we will just pick the kth element and we will return to the result. So this is the approach. Let's understand step by step. So firstly we will create one third array. After that we will store all the element from both the array in a sorted manner. After that we will pick the kth position element and we will return that as a result. So let's come in a code editor. So I hope that yeah. So to save the time, I have already written the code in the Java language, and you will get the other language code like C++, Python on my GitHub. That link will I put on the description of this video. So let's see that this is the first approach, okay, which I have solved with the help of by third array. Yes. So let's understand the code first. Okay, so as this is the function. Okay, so well I have created separate function for the approach 1. So there are two arrays given, array 1 which is a, and array b, and the kth which we need to find out the position value. So at the initially we have calculated the length of the array a and b as well, and we have taken the three pointer x, I and j. I will point to the eighth point, I pointer will point to a array, j pointer will point to b array, and x will point to the third array index. So let's see here. I have executed the loop until I less than n1 and j less than n2. After that, if let's assume that might be possible that both the array doesn't have the same number of element. So if array A has more number of element than array B, then this loop will like exit, but still we have some element which are present on the array A. So in that case this condition will execute. But if in the reverse, if the B array has more number of element compared to A array, then this condition will execute. At the end we will return k minus 1 position element of the C array. So let's talk about the time complexity to solve this approach. So as we are traversing each and every element of both the array, so in the worst case the time complexity will be order of n1 plus n2, where n1 is the length of the array, where n1 is the length of A and n2 is the length of second array. And if I talk about the space complexity, so yeah, in the worst case, as like we are creating separate array to store all the element, so in that case the space complexity will definitely be order of n1 plus n2, because we are putting all the element in a separate array. So yeah, this approach is not that much optimal. So let's comes in an optimal solution. How can we optimize the time as well as space complexity? So let's the approach to is what we can reduce the space complexity. We don't need to store all the element. As in the question is given, we just need to find out the element which are present on the kth position. So it means we don't need to store all the other element. So this is the approach to. So we don't need to create another array, and we don't have to store all the element. What we will do, we will follow this approach 1, but we will not store the element. We will just iterate all the element, and we will take another pointer which will point the current value of the current index, and we'll iterate all the element until we find out the kth position. After that, after getting the kth position element, we will return that element. So let's comes to the code editor. So in the approach 2, like here simply we will take another variable called temp, which will store the current index value. So we will execute the same things what we have done earlier. So we just don't store the element in the separate array. We just mark whichever element we have visited. We just store on the temp variable, and whenever we will get, if the current position is equal to k, then in that case it means we got that element, so we will simply return the answer which are stored in the temp variable. So if I talk about the time complexity of approach 2, so yeah, so approach 2, the like as here also we need to iterate each and every element of both the array. So the time complexity is remains same as order of n1 plus n2, but we have optimized the space complexity. Now the space complexity is constant. Why? Because we are not taking the extra space. So the space complexity is constant. You don't need to take another extra space to solve this problem. So can we optimize the time complexity as well as we have optimized the space complexity? Yes, definitely we can optimize. So let's see the optimal solution of this approach. So now that comes to approach 3, which is a binary search. So binary search is an efficient searching algorithm. As how we can think about the binary search, as the array is sorted and we need to search a specific element which are present at the kth position. So when sorted array and searching comes, then in that case definitely binary search work efficient way. So let's understand how binary search can be implemented here. So there is a step-by-step algorithm which I have written here. So firstly we have to choose how many elements. Let's assume that this is the given array. So this is the given array which we have got. And we need to find the fifth question element. So what we can do here, let's assume that can we take all the fifth element from the array A or 0 element from the array B? Yes, we can. So let's assume that the step 1, let's assume that we have picked 2, 3, 6, 7, 9 as we have picked the all the element, as the remaining element is not any element as remaining, so the is empty. Now as we need to find out the fifth element at a fifth question, so already we have taken all 5 element from the array A, so we don't need to take any another element from the array B. So yes, we cannot take. So all the remaining element will be at the right part. Now check here. As it is satisfying the condition, no it is not. So it means that this partition is not valid. So we have to find out, we have to partition the array in a valid way. So let's understand. Firstly we have to choose how many elements to take from the array A, as well as how many elements we have to take from the array B. This partition will helps to implement the binary search. So what we have done here, let's see here. Initially we have taken all the 5 elements from the array A and 0 element from the array B. But after that this is not satisfying the condition, because as the array is sorted, so the left element should be less than or equal to the right element, but it is not. So this partition is not valid. Let's try to do different partition. So what I have done here, we have picked 4 elements from the left side from the array A and we picked 1 element from the array B. So now the 2, 3, 6, 7 from the array A and 1 element from the array B. Now the array A, the remaining element is 9, and from the array B the remaining element left 4, 8 and 10. Got it? So now let's see about this step. Now see here, is it satisfying the condition of sorting? As see here, yes, this is satisfying condition. But see here, but 7 is greater than 4, but it is not true. The left side must be less than or equal to right. So this is also not satisfying the condition of sorting. Let's see step 3. Again we have done different partition. We pick 3 element from the array A and 2 element from the array B. So when after picking the 3 element from the array A, 2 3 6 and 2 element from the B, 1 4. So the remaining left element from the array A is 7 9 and the remaining element from B array is 8 10. So let's see here. Yes, this, see the diagonal. Yes, this satisfying the condition of sorting. See if 6 is less than 8 as well as 4 is less than 7. So this partition is valid. So after doing this partition, what we need to see here, at the end, at the left max is 6 and this array the left max 4. So what we have to do here, we have to find out the max between L1 and L2, right? So out of 6 and 4 the maximum is 6, so 6 is the our answer. So let's see the algorithm. We have to choose how many elements to take from the A as well as how many elements we have to take from the array B. After that we have to implement the binary search. So for binary search, as we know the formula, low plus high divided by 2. Okay, and we have to find out the mean. So we have to specify the range. So now the low will must be between G. The low will have to initialize either maximum of 0 or k minus n2, and high must be initialized with minimum of out of n1 and k. Whichever is minimum, we have to initialize with that. After that we have to border of the partition. We have to initialize left L1, L2, R1 and R2. Initially we have to initialize with the infinity. L1 and L2 will be initialized with the minus infinity, and R1 and R2 must be initialized with the positive infinity. So after that we have to check the validation partition, that if L1 less than or equal to R2 as we have done here, right? Like see here, L1 is this one. L1 must be less than or equal to R1, but is not. So this condition is not true. So we have to validate the partition. Well, then L2 must be less than or equal to R1. If this is true, then it means that we have got the valid partition, and in that case we will return the max out of L1 and L2. So after that, if this partition is not true, so in that case we have to move the search window. So if L1 is greater than R2, it means that we took many from A array, so we need to move left. Else if L2 is greater than R1, it means that we took many from the second array, so we have to move R1, right? So if I talk about the time complexity, so as we are implementing the binary search, so in the worst case the time complexity will become the order of log n, where the n is nothing but the number of total number of elements from the array A and B. We are talking about the space complexity. So as we are not taking any extra space, so space complexity is constant. So this is all about. Let's see the code, how it is working really. So this is the third approach code. Kth element F3A, as we have take the two array A and B and the kth element position. So initially we have initialized low pointer as low pointer which will be maximum of out of 0 or k minus n2, where n2 is the length of the second array, as well as we have also initialized high equal to math minus math dot mean. So out of n1 and k, whichever will be minimum will be assigned to high. Now we have done, after that we will execute this loop until low less than equal to high. At the first we have calculated the mid value, as we know the formula low plus high divided by 2. After that we will initialize the L1, L2, R1 and R2. L1 and L2 will be initialized with the minimum value, and R1 and R2 will be initialized with the maximum value. After that we have done, we have we have initialized the L1 and R1, R2, L2. After that we check here validation. If the partition is valid, then in that case we will return the maximum element of L1 and L2. If not, then we will update the window size. So this is all about the code. So let's try to execute this code and see here if it is working properly or not. So yeah, definitely it will. So this is the most optimal solution by using the binary search. So let's see. Yeah. Yes. So this passed all the test cases. So that's all about for today video, and I hope you have you understand the question and as well as solution, and you will got all the coding part in my GitHub. So till then, thank you so much for watching this video. Till then, bye bye, take care.